Hello and welcome to this presentation on our paper Project Smells, Experiences in Analyzing the Software Quality of Machine Learning Projects with mllint. My name is Bart van Oort and this paper was co-authored by my supervisors Luis Cruz, Babak Loni and Arie van Dorsen. A little bit about me first. My name is Bart van Oort, as I just said. I'm 26-year-old. I'm a software engineer and a DevOps engineer at the Energiebespaarders. But while I was writing this paper, I was doing my master thesis at TU Delft on the topic of code smells and software quality for machine learning projects. This thesis was done in collaboration with ING, specifically the AI for FinTech Research Lab, which is a 5-year collaboration between TU Delft and ING. They research anything relating to AI, data analytics, and software analytics, all in the context of financial technology and the financial technology industry that ING as a global Dutch bank. Now, what are we talking about today? I'll give you an introduction and some context around this paper. I'll tell you about what project smells really are. I'll explain about mllint, the introduction, a bit of an introduction. I'll tell you some goals that we set for mllint and some challenges in its design. Then we go on to evaluating mllint. I'll talk to you through the research questions that we posed in this paper and the methodology that we used to answer these questions. Then we'll go into the results and the discussion. So what did we actually find when applying this methodology? And finally, we go into the conclusion and take a look at some future work that might be possible. So first of all, as you probably know, machine learning and AI are pervasive in computer science. You find it anywhere from Google searches to medical appliances, to facial recognition, to recognizing objects within images, as well as specifically relevant for ING, transaction monitoring, know your customer analysis, all of these things that are relevant in the financial technology industry, and of course the most important one of all, dancing robots. But as much as it may seem so, machine learning is still not magic. It is basically just code and data put together, and this code and data needs to be written and needs to be gathered somehow. The people who do this are generally data scientists. They curate and shape the training data, they develop and they train the models that are being used, but often they're not from a software engineering background. And so they are mathematically very strong, they're mathematically very intelligent, but programmatically not so. So they don't have that much experience in writing software applications that need to function in a production environment. And productionizing code is already quite difficult, and especially in machine learning, where you also have data dependencies, and you also have your model training, which you could see as kind of a form of compilation, as well as the deployment. There's extra challenges in that. But in traditional software engineering, we've seen the implementation of a host of different tools to help with this software quality. Everything from Git to help with the version controlling of the code, the Kubernetes for the deployment of compiled versions of the code, testing frameworks for testing, and static analysis tools for helping to find bugs earlier and helping to improve software quality attributes such as the reliability, maintainability, and reproducibility of the software. And the list goes on and on and on, obviously. But as we've noticed, code smells that we can find with static analysis tools are only still a small piece in the software quality puzzle. We've noticed this firsthand in a paper that we wrote for the workshop on AI engineering last year, called The Prevalence of Code Smells in Machine Learning Projects. And what we found there, besides the most prevalent code smells in these machine learning projects, open source machine learning projects by the way, what we found were also some things that weren't just relating to the code. So the main takeaways from that paper were that in these open source projects there was bad dependency management practices. You had to manually edit some of the requirements files in the repositories of these projects so that we can even install these code dependencies. And we also found low static analysis tool adoption. There was almost no configuration for linters such as PyLint or Black or MyPy in any of these repositories. So that's what led us to the idea that, well, code smells is just a small piece of it, and we need to have a more holistic view on the software quality of machine learning projects. And so we came up with the idea of project smells. Project smells are a more holistic perspective on the software quality of machine learning projects. And they're concerned with deficits in how a machine learning project is managed. Now, as I said, I was doing this research for my master thesis, and I wanted my master thesis to have a practical impact, to have a tool, to produce a tool that would actually be usable by practitioners in the field. Something that would help them improve the software quality of their machine learning projects. And so I started implementing a tool for detecting and mitigating such project smells. So first of all, I started orienting on machine learning project best practices as posed by Software Engineering for Machine Learning, SE4ML, and Google's rules for machine learning. And then I did a measurability estimation to see, well, to what degree is it really possible to measure the adherence to a specific practice based on the project's repository in some kind of an automated way. And I labeled them green if they're really well possible to measure, red if it's basically impossible, and yellow if it's possible but with some caveats. Now, what is mllint really? Mllint, in a formal definition, is a command line utility to evaluate the technical quality of machine learning and artificial intelligence projects that were written in Python, and it does so by analyzing the project source code, the data, and the configuration of supporting tools. Now, mllint is open source. You can find it on GitHub, and it has 59 stars as of this recording. Now, while designing mllint, we had a number of goals, 3 specific goals, and these were for specific users, end users of mllint. The first being for data scientists and ML engineers. I wanted to give them a tool to create and maintain production-grade machine learning and AI projects. And I wanted this tool to be usable both on their personal computers as well as on automated CI systems. Then for machine learning practitioners that are inexperienced with software engineering techniques and tools, I wanted mllint to be able to help them explore and make more effective use of battle-hardened software engineering for machine learning tools that exist within the Python ecosystem. And finally, for machine learning project managers, I wanted to give them a tool to help them assess the machine learning project's quality and to give them some tips and recommendations as to what they could do in order to improve the software quality of their project. Now, there were a number of challenges in designing mllint. The first being SE4ML and Google's rules for machine learning have a bunch of best practices, but these are rather high level. For example, they say, one of them says that you should use static analysis. Well, sure, but which static analysis tools should we use, and are there specific rules that we should enable or should not enable or should not care about? And that may of course differ per team, but the way we try to approach this problem was to first do a measurability estimation, as I just explained. So what rules can we actually measure the adherence to reliably? And we also looked at the industry, what tools are being used in the industry, specifically of course within ING, and what can we find open source that is being used a lot. And of course we also used input from experienced machine learning engineers at ING. But then there is a second problem, a second challenge, and that second challenge is with the heterogeneity of machine learning projects. There are so many different kinds of tools, kinds of ways that you can make a machine learning project. It can be just a plain Python project with just a few small libraries, or you could be using a whole framework such as PyTorch or TensorFlow. This might change which tools you actually need to use in order to adhere to those best practices. Next, there's also the axis of the maturity of the project. So a proof of concept project, one that is kind of still in development, doesn't need as strict software quality practices as production-ready projects do, as a project that might be in production already or being deployed in production tomorrow. Now, I must say this is still an open challenge for mllint, but the way we tackled this in the implementation of mllint was through, first of all, configurability, being able to configure mllint's linting rules so that you can adjust them to either what your team uses or what your company wants or what your team or company has as standards. And as well, and then we have also custom rules, and those allow you to verify whether custom practices that you have within your team or your company to be able to implement them as a simple script and to be able to verify whether they work. Now, in order to evaluate mllint, we had a bunch of research questions. The first one being, how do these project smells that we've outlined as they're detected by mllint fit the industrial context of a large software and data intensive organization such as ING? Second research question is, what differences do ML practitioners perceive in the importance of mllint's linting rules between proof of concept and production ready projects? The third one is, what are the main obstacles for machine learning practitioners towards implementing these specific best practices? And finally, our fourth research question is, what are the perceived benefits of using static analysis tools such as mllint in order to verify software engineering practices in machine learning projects? To answer these questions, we had a mixed methods approach, mixed methods methodology, and this consists of two parts. The first being a qualitative analysis of mllint reports. So we gathered 8 machine learning applications from ING. We ran mllint on those, and we then did a manual inspection of the reports that mllint produced for these projects. And then we looked at these. So we looked at these reports to see, well, what are the key ideas? What are the things that people are implementing or are not implementing? And then we discussed these findings both within ourselves as authors, but also with experienced ML engineers within ING. The second part of our methodology consisted of a survey. And the survey was hosted within ING, but also publicly. Most of the participants were ML engineers. What we did with the answers of the survey was we codified all of these answers, especially the open answers, and we looked at what are the common themes there, and again discussed these findings with with experienced ML engineers within ING. Then onto the results and discussion. What we found in applying this methodology was distributed over 3 different themes. So the first one being data version control practices, second one being dependency management practices, and the third one being about static analysis tool adoption. Firstly, on data version control, we found that no projects were using DVC. And I must note there that DVC refers to the specific tool DVC that implements a way for doing data version control. But still, there are of course various ways for managing data, and we noticed various ways in these projects in which people were managing their data, each with varying degrees of version control. But all in all, it seems that like we have Git for doing all of the version control relating to code, we don't have such a similar tool for dealing with data dependencies. Next, on dependency management, even though it is perceived to be very important for proof of concept projects and absolutely essential for production ready projects, we did still notice that it is not done consistently well. Sure, it is done better in this industrial context than in the open source context that we saw for the Wayne paper. But we do notice that the practices still differ between people and projects. All in all, we still notice that it becomes apparent that Python has a lack of a standardized and easy to use and maintainable method for managing code dependencies. And finally, regarding static analysis tool adoption, there is a tendency against the usage of static analysis tools in the development phase of a project, but they are rather more used as a after-the-fact quality check during the productionization of the project, so in making the project ready to go into production later. There are a few reasons that we found why this might be the case. I'll name two of them here. These are also corroborated by existing research. And the first one being a high rate of false positives, especially in Python. It is difficult to do static analysis relative to statically typed languages such as Java and Golang. So that makes it less likely for people to want to use them, because they'll end up having to mitigate all of these false positives. And in mitigating them, they have to edit the configuration of the linting tool. But the thing is, it's also kind of difficult to configure these linting tools. For PyLint, for example, there are a plethora of rules for which you have to decide, do we want this within our team or do we not? And that can be really time consuming and difficult. So finally, we noticed that there is a need for context aware static analysis tools. Static analysis tools that are able to recognize what the project is currently about, what kind of tooling the project is using, as well as the maturity of the project. So in conclusion, I've introduced the concept of project smells. We have shown you the implementation of mllint, a tool to automatically detect and help to mitigate these project smells. We've been looking at the research we did in evaluating mllint and seeing whether the concept of project smells, as well as a tool such as mllint, is usable within an industrial context like that of ING. For some looks ahead towards future work and the topic of project smells, there's still some work to be done. First of all, it could use with a formal definition, more or less outlined it as a more holistic view on software quality that takes into account, that is concerned with deficits and how a machine learning project is managed. But it can use with a more formal definition. Next, it would also be interesting to look at the observable impact that project smells have on software quality. In this research, we investigated the perceived impact on software quality, but the observable impact on software quality would be more interesting. Next, for mllint, the tool is far from completed and far from fully featured. There are still a load of different tools and practices to look at and to enforce. The first one that I would recommend being a data quality linter. So are you using great expectations or TensorFlow data validation to conduct effective quality checks on the data that you are training your model with? But also adding a linter to detect ML-specific code smells, those that are outlined in Scully et al.'s paper, for example. And there's, of course, much more different rules that you can implement. And finally, of course, you can make mllint context aware, make it be able to recognize or make it be possible to configure that, hey, my project is a proof of concept project or it is a production ready project, and it needs more or less importance attached to specific linting rules. Finally, we believe that there's still a lot to be done in educating machine learning practitioners, both educating them on relevant software engineering for machine learning tools and practices that they can use in their daily development, but also in learning to set up internal best practices for their team or for their company to produce machine learning projects of better quality. Thank you very much, and see you in the Q&A.